All right, guys. This is problem number 33 from section 8.2, and it is quite a bit harder than most of the others. I'm guessing most of you are stumped on this. Most of you breezed through the first part, and then you got to this problem and just stared at it for 20 minutes. So I figured I'd make a video and send it out to you guys so you have something to go off of. If you have any questions on it, still ask and I could explain it deeper or Zoom with you one-on-one or whatever to make you understand it. But hopefully after watching this video, it'll make more sense to you. All right, so all I've done is I've taken this picture here and I've kind of redrawn it over here just because I'm really scatterbrained. And so I have to simplify things as much as possible for my poor little brain to be able to process it. Okay, so this is basically the same pictures over here, at least the important parts. All right, so because I have a right angle here and a right angle over here, that tells me that AD is parallel to BC. Okay, so I know AD and BC are parallel. Well, because these are parallel, actually, I'm going to delete a few parts of these. That's a right angle that comes to here. All right, I'm just going to look at these two triangles now. So this triangle here and this triangle here. All right, so because AD and BC are parallel, I know that angle A here and angle C here are alternate interior angles and therefore they're congruent. Okay, I also know that angle D and angle B are alternate interior angles, and so they are also congruent. Therefore, I can say that triangle ADE is similar to triangle CBE by the angle-angle similarity theorem. Okay, now because they're similar, I can write a proportion, and I can say that AD is to CB as DE is to BE. Okay, now AD, guys, is 40, so 40 over 30 equals DE over BE. Now I can simplify this a little more to just 4 over 3 equals DE over BE. Okay, so I don't know the length, but I know the scale factor. Okay, so if DE is 4, then BE has to be 3. If DE is 8, then BE has to be 6. If DE is 12, then BE has to be 9. Okay, it's going to be in a 4:3 ratio. So what I'm going to do is I'm going to write DE as 4x and BE is 3x, because if my x is the same, these would always be in a 4:3 ratio. Okay, now I'm going to go back and I'm going to draw the ground here, and I'm going to draw my EF. Okay, and I'm not going to look at the triangles I just drew anymore. I'm going to look at B, C, D, that triangle. So here, here, and here. And then I'm also going to look at this little triangle within it. Okay, so I'm also going to draw this EF. And I know I have a right angle and a right angle. I know this is 30 feet, and this is 4x, and this is 3x. Okay, so both of these have a right angle, but they also share angle D. Okay, so I can say these triangles are similar by the angle-angle similarity theorem. So I can say, I'm going to come all the way over here, that triangle EFD is similar to triangle BCD by the angle similarity theorem. Okay, and therefore I know that BC, or I'm going to keep it steady with this, so I'll do EF first. So EF is to, so first two is to BC, as ED, so ED first and last is to BD. Okay. All right, so let's look. EF, I don't know. I'm going to call it, I don't know, let's call it Z. Z over BC is 30 equals, well, ED, I know is 4x, equals, well, guys, BD, if this piece is 4x, this piece is 3x, this whole thing is 7x. All right. And if I look right here at 4x over 7x, doesn't that just reduce to 4 over 7? Okay, so I'm going to rewrite this and say z over 30 equals 4 over 7. X over x is 1, so you can just cancel those out. Okay, well now I just have a proportion. So I can cross multiply. So I can say, let me get a different color so it doesn't run into the other ones. 7z equals 30 times 4 is 120. Divide by 7, divide by 7. That goes away. So z is 120 over 7. Here is your final answer.